Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. So we're going to be working on lab number 2 for basic electronics. And here it says to determine the total current going through the circuit below. Now in this case we have what's referred to as a parallel circuit. So I want you to think of this. Okay, do you see how we have the power supply over here? Notice how this resistor is in parallel. I want you to think of a line going down here like this. Think of a line going down here like this. This line is parallel to this line, which is parallel to this line. So that's why we call this a parallel circuit, because this resistor is parallel to this resistor, is parallel to the power supply. When you see this type of pattern, then we say this is a parallel circuit. So this is what's going to happen. Current is going to go from the battery, it's going to go out of this wire, but at this point right here, it splits. Part of the current goes over here, part of the current continues over here, and then this current comes over here, this current comes down here. They both meet over here, so right here and right here, they meet at this point, and then they continue on back through the battery, and then so forth. Split, part over here, part over here, over here. Part is coming down. Whoops, sorry, undo. Part of that current is coming down here. Part of this current is coming down here. They get together over here, combine again, and then go back up, so forth and so on. So that is how current goes through a parallel circuit. All right, in terms of the solution, we are still going to use our formula V is equal to IR. And since the resistors are in parallel, as you can see over here, we therefore apply the 5-volt voltage drop across both resistors. So here's the thing that you can know about parallel circuits. See this point right here? That's the same thing as this point right here, which is exactly the same thing as this point right here. See this point right here? That's exactly the same thing as this point over here, which is exactly the same as this point over here. So in other words, if I had a voltage meter, and if I put the voltage meter right here, and if I put the voltage meter right over here, I would get 5 volts. If I touch that voltage meter over here, and if I slide it over, so from here, I've slid it over to here. And if it's touching over here, I slide it over here. Again, it's still going to be 5 volts across this resistor. If I take that voltage meter that's right here and slide it over, and over here I slide that over, the voltage meter right here and right here, it's going to read 5 volts across this resistor. So in other words, a circuit that is in parallel, the voltage across this point over here is the same thing as the voltage over here is the same thing as the voltage over here. So in other words, this resistor has a 5-volt voltage drop. This resistor also has a 5-volt voltage drop. And so that's why I can use the formula V is equal to IR and solve for the current. Okay, so I illustrate that over here, that the current is being split. Part of it's going down over here, part of it is going down over here. Again, you notice that I have my formula, V is equal to IR. So I solve for I. I is going to be equal to the voltage divided by the resistance. Okay, so if that's the case, what is the current going through this resistor over here? So we call that IR1. In other words, the current going through resistor 1. Well, I know that the voltage drop is 5. I know from above over here that I have 2 kilo ohms, and so that's the 2K over there, which is the same thing as 5 divided by 2,000, which is the same thing as 0.0025. But electrical engineers don't like doing this. We like to have suffixes. So we say that that's the same thing as 2.5 milliamps. And the way that I got that is I just start from the decimal here, move 1, 2, 3. Well, 3 is milli. If I move 3 more, that would be micro. All right, so 3 milliamps, but we write it like this, 2.5 MA. All right, now let's determine the current going through the second resistor. Well, that's going to be called IR2, right? So this is the IR2, the current going through the resistor. Well, that's a 4K, right? As you can see over here, that's a 4 kilo ohm resistor. So 5 divided by 4K is the same thing as 5 divided by 4,000, which is 0.00125. Well, that's the same thing as 1.25 milliamps, but we don't write it like that. We write it like this, 1.25 MA. Okay, so therefore, the total current that's going through the circuit is really determined by adding the 2 individual currents. So I know the current going through one resistor, I know the current going through the other resistor. If I add those up, I get 3.75 milliamps. So in other words, the current coming out of the battery is 3.75 milliamps. Part of that gets split over here, part of that gets split over here, and then they both get recombined at this point right here. So at this point, it's going to be 3.75 milliamps, and then we go through the same thing all over again, right? So the part of the current is coming down R1, part of the current is coming down R2. It recombines at this point, right? And it splits, of course, at this point. Part of it's going over here, part of it's going over here, so forth and so on. So that is how we determine the total current for a parallel circuit. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.